Hello, we're still on Air Pollutions Unit 7. This is section 7.6 on how to reduce air pollution. Our objectives is to explain how air pollutants can be reduced at the source. And there's multiple different ways that we're going to be looking at this. Reducing emissions. Reducing emissions means we have to reduce the air pollutants. We drive less, and instead of driving, we walk, bike, or use the bus more. Or we go via Zoom. We conserve electricity. We use electric appliances that are much better. We also eat more plants and less meat. Why? Because if we have meat, we have to supply energy to not just for the meat, but also for the plants that the meat eats. We use renewable non-pollution emitting energy such as solar, wind, and hydropower. We have laws that can help us. The Clean Air Act was established a long time ago that allows the EPA to set acceptable levels for certain air pollutants. They monitor the emissions from the power plants and other facilities, and they can tax, sue, or fine corporations that release emissions above the levels set by the law. The CAFE vehicle standards, corporate average fuel economy standards, require the entire United States fleet of vehicles to meet certain average fuel economy. So it requires vehicle manufacturers to work to make more efficient vehicles. The more efficient vehicles burn less gasoline, release less NOx, particulate matter, carbon monoxide, and carbon dioxide. Sometimes we give pollution credits. It's similar to what we saw back in previous unit about fishing, where they had individual fishing quotas. And with that, if they didn't catch all their fish, they could sell their extra quota to other people. Here, companies that reduce their emissions well below the level earn pollution credits. And they can sell these to other companies so that they can meet the standards. How do we reduce vehicle air pollutants? When we buy gasoline, there's a vapor recovery nozzle. Look at the nozzle and you can see the black portion there. It captures the volatile organic compounds released by the gasoline fumes during refueling. The separate tube inside the nozzle captures the vapors and returns them to the underground storage tank, where it will precipitate back down into the gasoline, the liquid. This reduces the volatile organic compounds, which contribute to smog, especially the ozone production, and volatile organic compounds also irritate respiratory tracts. Reduces benzene, which is a carcinogen, which is also released from gasoline vapors. Also, they have put in catalytic converters. All catalytic cars produced after 1975 require catalytic converters. They contain platinum and palladium that bind to nitrous oxides and carbon monoxide. This catalytic converter converts the nitrous oxides, carbon monoxide, and other hydrocarbons into CO2, nitrogen, oxygen, and water. So as it goes through the palladium or platinum, it converts it from nasties to good stuff. So if you want to reduce your sulfur oxides and nitrous oxides, the acid producers, you add crushed limestone in the coal power plants. What happens is the crushed coal mixed with limestone, they do that before they add it to the boiler. The calcium carbonate combines with the sulfur dioxide to produce calcium sulfate, therefore reducing the sulfur dioxide in the being emitted. The calcium sulfate can be used to make gypsum wallboard or sheetrock for home foundations, making it so that it's less likely to have the acid up into your homes. So what happens here in the factory is that the coal and the limestone are mixed together, goes down into here where it's heated up, and therefore the it reduces the amount of sulfur dioxide because the calcium combines with the sulfur dioxide, so it does not go out into the air. Sometimes there's a fluidized bed combustion, where the fluidized jets of air are pumped into a combustion bed. The jets of air bring more oxygen into the reaction, making combustion more efficient, and bringing sulfur dioxide into more contact with carbon calcium in the limestone. It allows the coal to become combusted at lower temperatures, which emits less nitrous oxide. So it gets rid of the sulfur dioxides and the nitrous oxides. Wet and dry scrubbers. In dry scrubbers, it gets rid of the nitrous oxide, sulfur oxide, and volatile organics. Here, there's a large column, tube, or pipe filled with chemicals that absorb and or neutralize the oxides from the exhaust steam. And this calcium oxide is a common dry scrubber material, and it reacts just like before with sulfur dioxide to form calcium sulfide. So this would be the dry scrubber where the material goes up here. So basically what here happens is the waste air goes through here, goes through the media, the limestone, and therefore it doesn't go out into the atmosphere. Or we could have wet scrubbers. In wet scrubbers, there are many chemical agents that can absorb these things. And what happens is it's added as a mist at the top, which drops down, and then it absorbs these things in the bottom. And that goes through and is taken care of. These droplets with pollutants and particulate matters are trapped, fall to the bottom of the scrubber, and get eliminated by the mist eliminator down in here. The collection traps it, and therefore it can be used either to make sulfuric acid for the chemistry teachers, or for swimming pools or something like that, or just to be reused. Reducing particulate matter. This can be done either in the factories or in homes. I've seen it done in homes, where power plants especially pass through a device where one side is positive, one side is negative, and the particles go to one side, either one side or the other, and are trapped. The negative charge particles stick to the positive, and the positive stick to the negative, trapping them. Then the plates are discharged occasionally so that the particles drop to the bottom, so that it can be taken to landfills and disposed of. Baghouse filter, what happens there? It's a large fabric bag that traps the particulate matter as it goes through. These things are also shaken, so all the particles go to the bottom. And so that it doesn't get completely and totally lined with the particles, it's shaken all the time so that the stuff falls out. So the practice FRQ. What we have here on the y-axis is miles per gallon. On the x-axis are years. And you can see that the black line is historical data. The orange lines are the CAFE, whereas the Obama standards are up here. Question is, make a claim about the effectiveness of the Obama CAFE standards as an effect to reduce the levels of nitrous oxides in urban areas. Justify your claim with data from the graph. Hopefully this was helpful, and thank you so much.